Good morning to one and all. My name is Ayavas Reddy from 2nd MCCS. Today we are discussing about constraints in specialization and generalization. What is constraints? Constraints is a rule applied on ER model basing on disjoints and total participations of entity occurrence. Constraints are four types. One, disjoint constraint. Second, overlapping constraint. Third, partially completeness constraint. Fourth, total completeness constraint. Okay, now we can write. Constraint is a rule applied on ER model. First point we can see. Constraint is a rule applied on ER model. Second point, basing on disjointness, total participation of entity is an occurrence. Basing on disjoint and total participation of entity occurrence. Now, constraints are four types. We know disjoint, overlap, partially completeness, total completeness. Now we can see what is specialization and generalization. Specialization means it is an top-down process of designing low-level entities, means subtype entities, from high-level entities, means supertype entities, one or more. Okay, now we are right. It is an top-down process of designing, means low-level entities which is subtype entities, okay, from high-level entities, means supertype entities or one or more. Means we can see an example. This is an employee is there. Here teaching is there. Here non-teaching is there. The specialization symbol is this. This is denoted by specialization. Means these are called subtype entities. Now this is called supertype entities. We know, means specialization goes at top down, okay, means low level subtype entities from high level subtype entities, supertype entities, means this way, okay, top down process, okay. Second we can see patient is there, and patient now we can see this is supertype entity. This symbol to represent in patient. This is outpatient. Okay. Now this is also top down process. We can see this is subtype entity, supertype entity. Okay, this is called specialization. All the attributes, okay, attributes of supertype entity are enhanced to subtype entities. Okay, now we can see generalization. What is generalization? It is an bottom-up process of deriving high-level entities, means supertype entities, from low-level entities, means subtype entities. It is an opposite of specialization. You know, all the common attributes or subtype entities are represented in supertype entities. First, we can write definition. It is an bottom-up process. First point, of deriving high level entities, means supertype entities, from low level process, means low level entities, subtype entities. Okay, second point, we can see it is an opposite to specialization, means it goes to top down process, it comes to downward process. Okay, now we can see an example. Here person has name, number, phone number. The generalization symbol is denoted as this type, rectangle. Person as customer, and another is employee. Employee has salary, name, and number also. Customer has phone number and number, name. Now this is, if you see, person. These are customers and employer. These are called subtype entity. This is supertype entity, we know. Now this process called bottom down process. Okay, this is the bottom down process, we know. All the common attributes, these are attributes, are subtype entities are represented, then supertype entities. Okay, now we can see constraints are 4 types. There are, first, disjoint constraint. Second, overlapping constraint. Third one, we can see partial completeness constraint. Third one we can see, fourth one, total completeness constraint. Okay, these are the 4 types of constraints. Now we can discuss the one by one. Okay, first we can see disjoint constraint. What is disjoint constraint? It is refers to fact that the all other entity occurrences of supertype appear in subtype entities without overlapping. It is called disjoint constraint. Okay, this type of can constraints related to whether or not entities may belongs to more than one lower entity set within a single generalization. Disjoint constraint means, first point, it refers to fact that the all the entity occurrences of supertype appear in subtype entities, okay, without overlapping. Overlapping, we also know, means any two are overlap, it is called overlapping. In this disjoint constraint, it is do not have overlapping. It is denoted as, means it is denoted by D shape. Another point we can see, it is denoted by circle D. Okay, it is also known as non-overlapping constraint. Okay, now we can see an example. This is an employee, and this is, we can see, denoted D circle. Okay, this doctor, this is mechanic, this is professor. Here one supertype entity is there, supertype entity is there, subtype entities are there. Now Sunil and Hemant are 2 members are there, and another Ram and Nikhil are there. Now Sunil is a doctor, Hemant is a mechanic, Ram is a professor, but Sunil is not a professor and mechanic. So these are not overlapping. We can see once again, Sunil is a doctor, Hemant is a mechanic, Ram is a professor, means Nikhil is an employee. These are, but Sunil is a not mechanic and professor. So this called overlapping without overlapping. And another name is the disjoint constraint. Okay, in the requirement of the constraint and is that an entity should not be belongs to more than one lower level entity set. Okay, for example, the entity of student type, an attribute, either an entity can be graduate or an undergraduate student, but cannot be both at the same same time. Okay, now we can see the overlapping of constraint. Overlapping constraint means in this category of generalization, within a single generalization, the same entity may belongs to more than one lower level entity set. For example, in the employee work team, assume that certain employers participate in more than one work team. The team entity set that are lower level entity sets of employee, those generalization is overlaps. Okay, this is called overlapping. Now we can write an definition of overlapping constraint. It refers to fact that the entity occurrence of supertype means appear in a more than one entity. This is called overlapping constraint. Means here we can see in disjoint constraint in with this have without overlapping. Means here only one person doing only one job, or doctor or mechanic or professor. Here overlapping constraint we can see the one or more. Okay, in a should means appear in a more than one entities. Okay, we can see and overlapping the entities means here we can see an example. Employee has there, here principal is there, here see we can see professors. Okay, employee means here we can see the first this is a super type entity, these are subtype entities. Okay, means Shushan and Parvesh, and we can see another person Alex. These are three members are there. Okay, Shushan is the principal. Shushan the principal of school, and he is a max professor also. And Parvesh is the botany professor, and Alex is the max professor. Okay, here we can see Sushant is the overlapping. Okay, in super type and in two subtypes. Okay, here we can see the overlap in the constraints. Okay, now we can see the last third one, partial completeness constraint. Here one point is I am not told. Here overlapping constraint is denoted by circle O. It is denoted by circle O. Means This is structure. This denoted employee means supertype, and down we can see the subtype. Okay. Now we can see partial completeness constraint. What is partially completeness constraint? Means it specifies that each entity in the entity set may not participate in relationship instance in relationship set. That is also called as optional participation. Okay. It refers to fact that if some entity occurrences of supertype participated in subtype entities. Okay. Now we can see it is denoted by symbol was dash O. Okay. It is denoted by dash O. Here employee is there. Means we can denoting the symbol dash O. Down subtypes we can see the principal and professors. Now Sushant is then principal. Okay. And Parvesh is the means what we can see botany professor. Okay. Here we can taking the only partially principal and professor, and we do not taking Alex means max professor. This is called partially completeness constraint. Okay. Now we can seeing the fourth and last constraint, total completeness constraint. Okay. Means total completeness partially constraint means what? Means a completeness constraint means that every linear supertype has a related entity in one of the subtypes. In other words, the union of the set of entity in the subtype equals the sets of an entity in the supertype. Okay. Now we can see the what is total completeness constraint. It refers to fact that all entity occurrences of supertype entity it participated in subtype entity also. Okay. Now it is denoted by symbol double dash O. means double dash O. Okay, we can take an example of total completeness constraint. This is an we can have an account in bank. This is an savings. This is called sober time entity. This is current. Sorry, account has there. This is denoted by we know double O double dash O savings. This is a current account. Okay, now here we can see total completeness constraints. We are using savings and current. Either savings are using the current in the time. The account are related to the both are, means that total completeness constraints are both are there in this. Here we can see account is there and holder is using savings and current as both time, and he is taking money with withdraw and deposit the current and saving the money. This is called total completeness constraint. Okay, this is the constraint in specialization generalization. Here the constraint is rule applied on ER model also. We can see the constraints of four types. What is this? These are disjoint concentration and overlapping constraints and partially completeness constraints and total completeness constraints. Okay,